Chapter 5 in last class period. We finished. I am going to start chapter 6. Let me share my chapter 6 slides. Can you see my chapter 6 slides?
Yes, sir.
All right. We are going to have a third test on chapter 5 and 6 in November. So we might postpone November 1st date to later date. Soon after we finish chapter 5, chapter 6, we're going to have test 3. So we are planning on that. Let me start on chapter 6. Chapter 6 is on solutions and colloids. This chapter 6 is about mixtures. So far what we talked about is elements and compounds, pure substances. We gone over pure substances. Now we are going to talk about mixtures. Let's see. I have to stop this. Mixtures are the most common substances, pure substances. There could be elements with another element, compound with another element, or different combination of compounds. Now, you have to understand what is the relation of mixtures to solutions and colloids. Solution is a name for homogeneous mixture. Main type of mixtures we're going to look into is homogeneous mixtures. They are also called solutions. What is then colloids? Colloids are also homogeneous mixtures, but the particle size of the substances that dissolve in liquids are larger. For example, milk is a homogeneous mixture. The particle size of milk proteins are large, therefore they scatter light. They are scattered, they are not transparent. The light won't pass through colloids. But the solutions which are as liquids are transparent to light, light pass through it. So basic difference between solution and colloids are solutions have smaller particle size of the substances dissolved in the solution. Colloids have larger particle size, therefore they scatter light. Solutions are transparent, colloids are opaque. Opaque means light doesn't pass through. These are the main definition of homogeneous mixtures. Basically, we are going over homogeneous mixtures in this chapter. Heterogeneous mixtures are complex. They are separated to their component before studying them. Therefore, we mainly find homogeneous mixtures in the form of solutions and colloids as the important types of mixtures, homogeneous mixtures. The most common types of solutions We're going to look into that. They could be two substances, homogeneous mixture of two substances in different phases. Gas, liquid, solid substance dissolved in liquid is one of the examples. Solid also could form homogeneous mixtures like alloys. Two metals can mix up homogeneously and form homogeneous mixture. We're going to look into that. We're also going to look into factors affecting solubility. That means how they mix up. Two substances mix up in each other. Since mixtures have two components, we have to come up with the concentration. You cannot just use moles. They are not pure substances. So in proportion to one compound, number of moles of other compounds is given as concentration. Among the solutions, most important solution is water solution. Water solutions are called aqueous solutions. Water is a good solvent. Therefore, we use them everywhere possible. If a substance is soluble in water, that's the solvent of choice because it's cheaper and abundant. Then we're going to look into colloids. Colloids have larger particle size of substance being dissolved in a liquid. Therefore, they scatter light. They are opaque solution. Out of the last topic is colligative properties. Colligative properties, as the name implies, properties of homogeneous mixtures that depend on the number of particles of solute that goes into certain amount of solvent. Solvent is the bulk part of the homogeneous mixture. So we're going to go over this. Once we go over this, you're going to understand. I am going to go over solution. Solution is the general name of types of solution. General name for homogeneous mixture. Solution doesn't mean it's a liquid. Aqueous solution, aqueous water is aqueous solution. It's a solution, liquid solution of water. It's called aqueous solution. Solution doesn't mean liquid in the broader sense. Solution has two components, therefore, because it's a mixture. Solvent is the major component. If you mix up two components, one becomes major, which is present in large amount. Solute is the component that present in lower concentration. Normally, properties of the solution are closer to properties of solvent because it's the major component. Solute is not the one that decides the physical state or properties of homogeneous solution. Let's look into different types of Let's look at major type of solution. A homogeneous mixture is the name we use for solution. Solution is homogeneous mixture. First homogeneous mixture that we find is, which we can call is gas and a gas. Air is an example. Air has oxygen and nitrogen and other gases. It's a homogeneous solution. Gas also could be dissolved in like carbonated water in liquid. Solvent has a liquid that decides the physical state of the solution, homogeneous solution. Gas dissolved in liquid is another type of. There are different combinations of two components based on a physical state. Gas dissolved in a solid. You can dissolve gas in a solid. For example, clouds are water vapor dissolved in ice. Normally, a form is formed shaving cream. Gas dissolved in a solid. It makes a cloud. Liquid and liquid is a homogeneous solution that are formed between two liquids. Example is wine. Wine has alcohol and water mainly. Therefore, two liquids, alcohol and water, is in the wine mixture. There are other components, coloring material, flavors. They are minor components. Main components is alcohol and water. Solid in a liquid is the most common type of solution. Salt water solution, also called saline solution, is the aqueous solution of salt and water. Saline solutions are given during the IV. Saline solution have salt and glucose that are given as IV fluid. Solid in a solid. These are different combinations. There are 6 combinations out of 3 states. Gas in gas, gas plus liquid, gas plus solid, liquid in liquid, solid. You start with the gases, then middle combinations are different combination of gas, liquid, solid. So you begin to understand this solution idea. Homogeneous mixture is a broad concept for dissolving different state of matter to form different homogeneous mixtures. I'm not going to go over instructional objectives right now. Once we done some, we come back and look into this. Characteristic of solution, homogeneous mixtures. Let's look at that. The distribution of particles is uniform. That's the meaning of homogeneous. The distribution of gas in a liquid, the gas particles and liquid particles are homogeneous, uniform. Component of solution do not separate on standing. Normally, a solution, either gas, liquid, or solid, the separation doesn't take place. Homogeneous mixtures, they stay uniform. Solution cannot be separated into components by filtration. Solutions have smaller particle size, like sodium chloride. You cannot filter out sodium chloride from water. So is the milk. Milk, even though it has larger particle size of solute, they cannot be, milk cannot be separated out from its components and water. One of the characteristics of a homogeneous mixture is you can mix up different combination of two components, solvent in the major component and the solute lower concentrated component. You can make millions of different combinations. Each different combination have its different properties. Therefore, we can mix up to obtain different properties for homogeneous mixtures by changing the solvent solute combination. Solutions are almost always transparent. Solutions are transparent when they are not colloids. Colloids are the ones doesn't apply to this one. Rest of the 1, 2, 3, 4 applies. Solution, normal solutions, which have smaller particle size, are transparent. Solid solution is exception. Solid solution have exception. Solid state is different from liquid state. Therefore, solid solution, if you have a mixture of homogeneous mixture of alloy, it's not transparent. Solution can be separated into pure components by physical change, not by chemical change. Mixtures are when you mix up two components, solvent and solute. There's no chemical reaction, direct chemical reaction between the solute and the solvent. Therefore, only physical change can separate mixtures into components. For example, sodium chloride and water, salt water. Water could be boiled off, leaving the sodium chloride. That's a physical change. Or chromatography. Chromatography is a technique based on physical properties of different colored substances that move through a solvent when change paper chromatography. You can separate chlorophyll into different components. That's a physical change. Let's answer a few questions to solidify what we learned. Which of the following is a solution? Blood plasma, cigarette smoke, milk. Blood plasma is has large platelets. Blood plasma is obtained from blood by filtering platelets. Cigarette smoke is kind of solid and gas. Milk is a colloid. Answer is none of these. All these are blood plasma as proteins, even though if you remove the platelets, therefore it's not a solution, it's a colloid. Cigarette smoke is large particles of carbon. Milk is a colloid, large particles of solute, milk protein. Therefore, none of these are classified as solution. In a solution, the solvent is substance present in large concentration. Greatest amount is the solvent is not always. Solvent could be different solid, liquid, gases, depending on the homogeneous mixture. Substance, this is the solute. Definition of solute substance being dissolved. Always water. That's not true. Only correct answer is C. A solution may contain only one solvent but many solutes. That's true. You can have a water solution and many sodium chloride and sugar, many solutes. That's true. May contain only one solvent and one solute. It may many solvent but only one solute. Many solvents and many solutes. It cannot have many solvents. That is not always. I confuse here. May means not always. Many solvents, and that cannot be many solvents. Solution may contain only one solvent. Only one solvent, but many solutes. Only one solvent and one solute. This is correct. This I am not sure. Only one solvent and one solute. But this is the most cases. Therefore, I think that's why they picked A. Which of the following can serve as solvent in solution? All of these. Solvent is the physical state of the homogeneous mixture is decided by the solvent. It could be a gas as major component, liquid as major component, or solid as all of these. Which of the following solute-solvent combination does the term metallic solid mixtures alloy apply? Solid-solid mixtures of metals are called alloys. This is the solid-solid. Liquid is not alloy, metallic. C is the correct answer. Which of the following combination will always result in a solution, homogeneous mixture? A gas is a combination where any combination of gas would still have the gas form for the homogeneous mixture of gas always result in a solution. Liquids, when you mix up, sometimes they separate out depending on the concentration of the one liquid. If you add more liquid, it separates out. Therefore, always result in if liquid separates out, they form a layer. Therefore, it's not a homogeneous mixture. Solid also have that problem, depending on the relative amount of solid and solid. Lower concentration of solid leads to alloy, solid solution, called alloy. Alloy is defined here. Therefore, this is not always result in the liquid, like liquid. Solid also can form at higher concentration. Two solids. One is the alloy, one is the precipitated out solute. Therefore, answer is A. Which of the following terms is used to refer to gas dissolved in a liquid? Gas dissolved in a liquid is solute. Liquid is a major component. Therefore, gas is the lower component. Therefore, C is the answer. Like dissolves like. Like dissolves like means solute and the solvent has to have similar intermolecular forces to interact with each other to form a homogeneous solution. These forces, like means hydrogen bonding, dipolar, London dispersion forces. If they are present between solute and the solvent, they have to be similar. These forces decide if something is going to mix up or soluble in each other. Dissolve means going into form a homogeneous mixture. They have to have similar structure with similar to the solute solvent, similar intermolecular forces. Ionic compounds are considered polar, therefore polar solvents dissolve ionic compound. The sodium chloride and water dissolve in each other. Non-polar molecules will be more soluble in non-polar. Therefore, non-polar molecules which has London dispersion forces will go and dissolve in each other. Polar molecules are not like non-polar. Therefore, they are not like dissolves like. Polarity-wise, the solute and the solvent has to have similar intermolecular forces. That's the idea behind like dissolves like. Solubility is the idea how much solute goes into certain amount of solvent at a given temperature. That's the solubility. Solubility is expressed in fraction of solute in the solution. You can express solubility in grams per milliliter, grams, 100 grams of solvent. Solubility is a physical constant. If different solutes in a liquid can have different solubilities, therefore it's a physical characteristic of a solute. Lower solubility in water, higher solubility. When solute become low in solubility, it's called insoluble. Insoluble means the solute comes out of the solution. The higher ability of solute to go into liquid or solvent is called soluble. Some liquids are insoluble in each other. Gasoline and water. There are two liquids. Gasoline and water doesn't mix up. It forms layers. Gasoline floats on the water layer. Other liquids have limited solubility in each other. Water and gasoline is an extreme example. Gasoline is polar. Water is hydrogen bonding. Non-polar gasoline is non-polar. Therefore, they are not like each other. Other liquids have limited solubility in each other. For example, ether is an organic compound with dipoles. Ether has this dipole, oxygen carbon. Therefore, it's little polar. Water is highly polar. Therefore, ether solubility is limited. When you add more ether, the ether separates out. So solubility is dependent on the temperature. Amount of ether is 6 grams per 100 grams of water. That's how we express solubility. Still other liquids are completely soluble in, for example, ethanol and water. Both have hydrogen bonding. Therefore, they are like hydrogen bonding. They have similar intermolecular forces. They completely mix up. Alcohol doesn't precipitate out, separate out when you add more alcohol or water. We're going to talk about type of solution based on solubility. Based on solubility, a saturated solution is having maximum concentration, maximum amount of solute that can be held at that temperature. For example, if you take a beaker of water, add sugar, and for example, little warm water, 60 degrees Celsius. As you add the sugar, it goes at 60 degrees. It dissolves. But after adding certain amount of sugar, it started to not dissolve. You can see sugar solids begin to accumulate. We're at that point where maximum amount of solute sugar are gone into water at this temperature, 60 degrees. That's the saturated solution of a sugar at 60 degrees. Solubility could be calculated by amount of sugar grams divided by amount of water in the solution. Unsaturated means before that saturation point is reached, there's not the maximum, less than the maximum amount of the solute. More than it exactly contains the maximum amount. Less than the maximum amount. More than this is called equilibrium. Here, sugar and water is in equilibrium. More sugar goes into water, less sugar goes into. Less sugar solution is unsaturated. Exactly the equilibrium sugar maximum that is saturated. Unsaturated is less sugar. If this supersaturated solution is when you keep heating a water and sugar, more sugar goes into, for example, 100 degrees. More sugar went into water. But when you cool off to 60, all the sugar doesn't come out. When the saturated solution at higher temperature cool down to lower temperature, a supersaturated solution results in the exact solute doesn't separate out. This is a metastable temporary state. If you have a supersaturated solution, it has more solute than saturated solution at the same temperature. If you put a seed crystal, if you have a saturated solution, you add a seed crystal. All of a sudden, all solutes come out of the excess solute, come out and make a lot of crystals. That is supersaturated. Now we're going to ask few questions about saturated solution, unsaturated, supersaturated. Which of the following statement concerning a saturated solution is incorrect? I'm going to mark the correct. Undissolved solid must be present. Saturated for saturated solution, undissolved must be present. This is, yes, correct for, we have to then negate it. Undissolved solute may not be present. That's not true. Unsaturated means, saturated means undissolved should be present. Undissolved solute, if present, is continually dissolving. That's not. This is correct. Undissolved solute may or may not. Some solution may have exactly the same. Undissolved should be present, continually dissolving. That's not true. Undissolved solute, if present, is in equilibrium with the. That's correct. Incorrect answer is this one. Therefore, let me go away. Undissolved must be present. That's correct. Undissolved solute, if present, continually. Undissolved solute, if present, is continually dissolved. This is before supersaturated. That's before saturation. It could be condition. Undissolved solute must be present. That's not a correct statement. Supersaturated. Saturated means it can have just exactly same amount of solute. That's why A is incorrect. Which term is used to refer to the solid component of the solid in liquid solution? Liquid is the solvent. The solid component is solid. This is the solvent. A crystal of sodium chloride into form in water, sodium chloride solution. It is observed that this means original solution was aqueous solution is the original solution. But when you add more, that means unsaturated. Now we got the answer. They are not talking about this solution. Most, but not all the crystals. Most, but let's go through more problems. Which of the following pairs of compounds form a solution? That's about like dissolves like. Definition. Out of these, that's ionic. This is non-polar. Therefore, pairs of compounds doesn't form a solution. Methanol and water have both hydrogen bonding, polar compounds. These two goes in each other. Octane is non-polar, London dispersion forces. Water is hydrogen bonding. Therefore, they don't have like intermolecular attraction. This is non-polar. This is hydrogen bonding. Therefore, they don't have like intermolecular forces. Therefore, answer is B. Which of the following statements best describe the solubility of a substance? The ability of the substance to dissolve in water. Seems to be correct. The ability of substance to dissociate into ions when dissolved in water. That's true. They break up ions. The maximum amount of substance that can be dissolved in specific amount of solvent. That's the solubility. The mass of the solvent necessary to completely dissolve. Best described. Maximum amount. That's the direct definition of solubility. This is the maximum amount that goes into solution. The best is this. Therefore, C. Which of the following statements concerning a solution is not true? Solution is a heterogeneous mixture. Solution is a homogeneous mixture. A solution composed of a solvent and most solute. The solute dissolve in the solvent. That's true. A solution has its components uniformly distributed. That's true. Homogeneous mixture. A solution is likely to form when the solutes and the solvent molecule have similar similar properties, polarities. A is not correct. Therefore, we got the answer. Which of the following is true of a solution? Components of the solution can be separated by filtration. We said they don't separate out. The components of a solute separate on standing. That's not true. Homogeneous mixtures doesn't separate out. A separation of solution into components is a physical change, is the one. There's no chemical reaction between two components. Therefore, they cannot be separating them is not a chemical change. Physical. The separation of solution into component is by physical change. That's correct. D is the correct answer. Let's look at solubility, general features. Non-polar compounds are soluble in non-polar. That's like dissolves like. The attraction of an ion with the dipole molecule is called ion with the dipole. Ion dipole. That's a polar. Between dipole is called dipole attraction. Hydrogen bonding. This is the ion dipole attraction. Which of the following describe an unsaturated solution? A solution that has less than maximum number of grams of solute dissolved. That's true. Less than maximum. A solution that has that's saturated. A solution that has more than that maximum, that's supersaturated. We are looking for unsaturated. None of the correct answer so far what I got is A. Which compound will be the least soluble in water? Least soluble in water is the non-polar compound. Water is a polar compound. Non-polar molecule is here. Butane, hydrocarbon. Water has hydrogen bonding. This has London dispersion. Therefore, is least soluble. Which of the following describe an unsaturated solution? That's the same problem. Therefore, answer is A. Which compound will be more soluble? This has dipole. This is a ether molecule with two hydrocarbons between one oxygen. That's dipole. This is hydrogen bonding, one hydrogen bond, OH. This got two hydrogen bonds. More soluble is this. Water got hydrogen bonding. Therefore, this got two hydrogen bonding. Is the more soluble. I cannot see the question. Least soluble. I was looking for more soluble. Least soluble is this. These are similar question. More soluble is this one. It got two hydrogen bonds. Which pair of compound will form a solution? This will form a solution like dissolves like. Benzene is a non-polar. Hexane is non-polar. Sodium chloride is ionic. This is hydrocarbon, non-polar. This will not form a solution. They are not like each other. This one is ionic. This one is benzene is organic. Therefore, this will form a solution. Water is polar. Carbon tetrachloride is non-polar. Therefore, they are not like each other. Only soluble compounds will be A, benzene, and hexane. Which interactions are responsible for? We answered the 38. Which of the following will be A is the correct answer. Which of the ionic compound is not soluble in water? We talked about solubility rules. These are ionic compounds. This is soluble. This is a solubility rule 1. This is insoluble. This is soluble. That's not the right answer. This is insoluble. Ammonium ions, salt with ammonium are not soluble. Therefore, acetate ion. This is the acetate. Therefore, correct answer is B. Which of the ionic compounds are soluble in water? This is the correct one. Nitrate are soluble. Barium sulfate is one of the sulfate. According to we go on our solubility rules. Iron hydroxides are insoluble. This is the soluble. Nitrates are soluble. All nitrates. That's insoluble. Therefore, correct answer is D. So solubility of ionic compounds in water is based on solubility rules. We go on over this. Out of these three, which are soluble? This is soluble. This is soluble. All nitrates. Therefore, 3 salts are soluble. That's the correct answer. Lithium chloride lithium is a group 1 cation. That's soluble. That's insoluble. That's soluble. There are about 2 out of 3 salts. B is the correct answer. For the set of ionic compounds, choose the correct characterization, then the statement. This is insoluble. This is carbonate ion soluble. This is soluble. One of the barium ion according to solubility rule. Therefore, 1 is soluble. C is the correct answer. For a set of ionic compounds, choose the correct characterization, their solubilities in water. This is soluble, sulfate. This is soluble. This is not. You check on the solubility rules. Therefore, B is the correct answer. This is 2. 2 are soluble. For the set of ionic compound, choose the correct characterization of their solubility in the water from this is not soluble, phosphate are not soluble, this is not soluble, this is soluble, 1 out of 3. C, effect of pressure on the solubility. We look at generally how intermolecular forces affect solubility. Now we are going to look at the pressure effects on solubility. Pressure has little effect on solubility of liquid or solid, but the solubility of gases are dependent on pressure. Higher the pressure above the solution, gases, high amount of gases goes into water solution. We're going to look into this in next class in detail. You guys are still here?
Yes, sir.
Next Wednesday, not next week. Wednesday is our next class, right? All right, I will see you next Wednesday. Thank you for coming.